Welcome back. This is video number 6, which is still about outputs. In this video, you will learn how to visualize, analyze, and check results for the network. And in this video, we focus on link results, node outputs, as well as the evaluation of journey times. So in Visum, you can display many of the link outputs in the network editor, and I would like to give you some examples how you can do that after a simulation-based assignment. So you are surely familiar with the display of volumes. So the difference here is now that you have also volumes per analyzed time intervals. So instead of having only the analyzed period, you have here also output for current intervals, it's called in Visum. Additionally, you find here a way how you can move through the time intervals. And by doing that, you can see the different volumes over time. So that is one way how you can visualize dynamic output from the simulation-based assignment. Another quite useful attribute is the density. Density is a good indicator for congestion. So you see, for example, hotspots and also localized queues. So here we have a classified output of density. Again, you can change that here to the beginning of the assignment period and move through the intervals. If you, for example, switch on in addition the node control for nodes and main nodes, you will see how the density changes in the vicinity of these controlled junctions. So that is also quite a useful output to spot congestion and to have in particular a first feeling of where in the network congestion occurs. Another attribute that might be quite useful is the speed. Also the speed changes over time intervals, and that can be displayed in the network editor. So in the same way as for density, you can create a classification that is appropriate for your network, and then move through the time intervals to check where the speed drops due to congestions or potentially also due to the control in the network. So here the dark colors indicate low speed and the light colors indicate higher speeds. So that are some examples. Of course, there are many more that you can visualize in the network editor. But of course, you have also link outputs in lists. And I would like to show you some examples that you can find in a list. So also here I will load a predefined layout to show you some attributes. And first I would like to draw your attention again to the attribute capacity, which shows here a shaded background. That has some reason, because as we mentioned in the simulation-based assignment, the attribute is not relevant. But if you use the hybrid option, of course, the attribute is relevant in the macro part of the network. So that is what you see here. These are capacities in the macro part and they need to be defined, whereas in the area where we simulate mesoscopically, this attribute is not taken into account. So here we focus on outputs from the area that is mesoscopically simulated. So again, you have attributes, for example, here the speed, that is an attribute that is over the entire assignment period, so it is the analyzed period result. But in addition, you have the output for current intervals, which we have defined as 15 minutes intervals for the calculation of the simulation-based assignment now. These attributes will change if you move here through the time intervals. So maybe we focus on a particular link. Let's choose this one. So you see here different attributes, and if you move through time, you can see that the value of the current interval will change as you move through time intervals. So, and for most attributes, you have these analyzed periods results and also the current interval. Then we had also mentioned already the density. That is also a quite useful output that you can analyze. And of course, in lists, it is always good because here you can sort your rows according to the value of the attribute. Yeah, in addition, you have outputs for queues. There are two outputs that come from the simulation. The first is the lane maximum. Note that in the simulation-based assignment, we have an estimate of queue length because here, as opposed to microsimulation, we do not use a step-based approach, but an event-based approach, and therefore we have to we cannot measure the queue length, but we do an estimate of queue length. So we have first the maximum, and in addition, you have the average queue length. So, and then there is another attribute which is called SBA utilization. So you can imagine that as a scaled density or something that is can be comparable to the volume capacity ratio in static assignments. So if you, for example, imagine a fundamental diagram of triangular shape, so a value here of 100% corresponds to the highest point, or in other words, to a situation where vehicles move with free flow speed at a headway equal to the reaction time. So values above 100% indicate congestion. So you are at a branch right from the top. So the speed falls below the free flow speed, and values on the right indicate that vehicles, on the left indicate that vehicles move with free flow speed, but the headways are bigger than the reaction time. So that is also quite a useful attribute that can be visualized and gives a good impression of where the network congestion occurs. And then there are some outputs that come directly from the simulation. It might be useful to know that because in case you debug, you might need to have a look at output from the simulation. So here you have the number of vehicles that enter a link in a certain time interval and the number of vehicles that exit a link in the current time interval. So maybe an overview of attributes that you can use. Of course, you will use the volume attributes that you know from static assignment, volume PRT in vehicles. You have that for the analyzed period and for the current time intervals. It might be also useful to have a look at volume attributes by transport system or by demand segment. Again, all these attributes are for the analyzed period, for the current time interval, and the specific time intervals. So these volume attributes are available in the entire network. Then you typically look at the travel time. Again, that is also here possible. You have the travel time for the analyzed period, for the current time interval and paired time interval. So again, this is available in the entire network. And then there are some attributes which I already showed you. So the density, the queue length with two different types, SBA utilization. So these results are available in the or on links that are mesoscopically simulated, but these attributes are not calculated for the part where we have macro principles. And if you dig even deeper, it might be useful to also look at simulation output. So again, that is available for the mesoscopically simulated links. And here you have different outputs that you can use for debugging purposes. Again, these attributes are only available in the mesoscopically simulated area. So these are some outputs available for links. Of course, there are also corresponding attributes for turns that can be looked at in lists. And what I would like to show you is an output that I find quite useful when I first look at a result from a simulation-based assignment. It shows the delay at nodes. In order to do that, I will look at the graphic parameter, and here in the graphic parameters you have the option to also load graphic parameters for certain network objects. I will do that now for nodes. And what I will display here is a chart, and this chart uses attribute from turns. So the turns have an attribute which indicates the delay on the turn itself plus the delay from the incoming link. And here we use the maximum of that attribute to show the delay at the node. Maybe for now we concentrate on signalized node, but it might be also useful to show that attribute for other control types. Or maybe I will switch off the link bars so we have a better impression. So again, here you can now go through time and you can see how the maximum delay at a node changes over time. And in case you have congestion, you will immediately see a big circle which indicates that you have here a huge delay, and that is typically something you need to look at. Of course, in this network we have also main nodes, so we should do the same for main nodes. Maybe I show you how to define this again. Again, we focus on signalized nodes. We activate the draw chart, use a pie chart, activate an attribute and choose the attribute for main turns, the maximum for the delay on the from link plus a turn delay. And then we maybe choose a different color here so we can see that it is about main node instead of nodes. Here we use the same scaling, define some useful attribute values for the lower and the upper limits, and draw the label. So maybe you can activate the preview first, so that seems to work. And again, we might go through time in order to see how the value changes. So here, for example, you have already a 2-minute value, which might be reasonable. That might be, of course, checked in relation to the cycle time of the node, if that is appropriate or not. And once you have identified such a node, you can, for example, look at the visualization. So for example, here we have that node, you have already the point in time, and now you can check here if you find some unreasonable queues over that period, and then analyze what might be the cause for that. So that is, in my opinion, quite a useful display to identify hotspots in the network using a node display. So I will switch that off for now. And now we come to journey times. Although journey times can be calibrated, and for that it is useful to define paths. Besides the path from the assignment, we have in Visum also user-defined paths that can be used for that purpose. You can also open a list for that. So in the top you have the assignment path, and then you have attributes for user-defined paths. I will open a layout. So here we have, for example, already a path defined in the network. And for such paths, we then can calculate travel time. Before I do so, maybe I would go back and show you how to define such a path. So you can do that by adding a path, select the corresponding path set, and then you can basically choose start node and move the path to appropriate end node. Check the parameters. We do not want to use close turns. And now I have a second path here defined. And now I can essentially select these paths, set travel times, choose appropriate departure times, the transport system, and what we actually calculate here are the experienced travel times. So they, of course, depend on the departure time, and if you choose a different departure time, they will, of course, also change. So for calibration purposes, again, you might add a user-defined attribute, for example, empirical travel time with the duration. You can add that to the list, enter your empirical data or calculate those from the link attributes, and then you can compare those to the travel times using the assignment output. There's also a list where you can check in detail. That is a path item list. So here, for example, we check the path number 2, which we have just created. And here you can basically move through the different path items and potentially compare travel times on these path items with some empirical data you might have available. Also in that list, you can set travel times with a reference point. Again, choose a corresponding departure time. And with this, again, you can see here the departure time, the travel time over the path, and so you can also compare that on a detailed level. Yeah, with this, we are at the end of this video. All these outputs that I have shown you help in the process of calibration. So that means during the calibration, we make adjustments to help the model to better represent reality, to better fit empirical data. And these outputs are quite useful in order to compare to empirical data, so which are typically counts, speed data, journey time data, to make these adjustments. However, before adjusting parameters, make sure that you have corrected any networks errors in order to do not set these parameters while you have still errors in the network. So here we finish with this video, and in the next video we will have a look at the demand calibration, or more specifically answer the question of how the demand profile can be adjusted using count data from different time intervals.